Hi everyone, welcome to Blink 2.0 series of video. This is Bhupender Singh and today I will show you how you can make a complete home automation project using Blink 2.0 with manual control while internet is available or not. This video is a little lengthy because I will explain to you each and every detail so that you can understand and make it by yourself. And guys, thanks for your views, likes and valuable comments. These things praise me for doing more videos on innovation and latest technologies. So guys, first of all, to make this project, you need the following components. Notify Wi-Fi board or Node MCU module, 3-channel relay to control 3 appliances, 1 12 volt 2 ampere adapter or power supply, 3 bulb or output devices, 2 to 3 meter AC wire, 3 push button for manual control, 3 10K resistor to connect with push button and few female to female connecting wires. And after it, this is the circuit diagram for this project. As you can see, here we take 3 switches that are connected to D0, D1 and D2 number pins of Notify and relay connected to D5, D6 and D7 number of pins. Here orange color wire denotes 12 volt DC voltage, red color wire denotes 5 volt DC and blue color wire denotes ground. You can download the circuit diagram from the below video description. Now let's introduce you to the hardware. This is a Notify Wi-Fi development board with the latest Wi-Fi firmware designed by Nutty Engineer Company. You can use Node MCU beside it. This is a 2-channel 12 volt relay. This is also designed by Nutty Engineer Company. We take one more 2-channel relay because I don't have a single channel relay, but I am going to control only 3 devices. And this is an AC bulb with a holder and wires. We take 3 bulbs with AC wires. These are 3 push buttons that we have soldered to the 0 size PCB. We have also attached 10K resistors with each button as per shown in the circuit diagram, and this is a plug for AC connectivity. Now we first configure the Blink web dashboard. So open the web browser and open the Blink Cloud website by typing blink.cloud. Here, if you are a new user, then create your new account, otherwise log in by your credential. We already have an account with Blink. After login, you can see the dashboard of Blink. Here you can create your first project template. So click on the new template and you will see the template property. Here you have to write your project name. Below, select hardware as ESP8266 as we are working on Notify or Node MCU, and choose the connection type is Wi-Fi. At the description, write your project description and click on done. Once you have done it, you will see the info tab where you see firmware configuration of your project. This is very important because we need to write it in our Arduino program. In the metadata tab, we can see the information about our project that we just created. Later on, you can edit it and put your additional information as per your requirement. In the data stream tab, we define the method of accessing the Notify board, as we can say how you are going to access your sensor or any input-output devices directly through analog pins, digital pins or virtual pins. Basically, we go through the virtual pins as it has many advantages. Let's define the virtual pins. Click on the new data stream and choose virtual pin. Virtual pin property gets opened. Write the name as switch 1, virtual pin as V0 and data type as integer and click on create. Similarly, we create another virtual pin for another 2 switches. So click on the new data stream, then virtual pin. In the property, write the name as switch 2, select the pin as V1, data type as integer and click on create. Create another virtual pin for switch 3, click on new data stream, then virtual pin. In the property, write the name as switch 3, virtual pin as V2, data type as integer and click on create. Finally, we have created the 3 virtual pins for our 3 devices. Now go to the events tab where you can create your events for your notification. This tab is very interesting, but we don't need it in this project. So go to the web dashboard. Here we drag and drop 3 switches to control the 3 devices from the web dashboard like this. Now hover the mouse cursor on the label and you will see the setting icon on the switch. Click on it. Property gets opened. Select the data stream as switch 1 V0 and click on the save button. Now go to the next switch and open setting. In the property, select the data stream as switch 2 V1 and click on save. Now click on third button and open setting. Select data stream as switch 3 V2 and click on save. We have created our switches in the web dashboard. Now click on the mobile dashboard tab from which you can get the link to download the Blink IoT mobile app for your iOS and Android mobile. Now click on save button to save the changes in template. Let's go for programming code. So go to the video description and click on the link given to download the test program for home automation. Note that first we need to upload the test code to Notify or NodeMCU, configure the Blink app. After that we work on the main programming code. Okay. Once downloading is done, you will get the WinRAR file with the name Blink 2 Automated SME Wi-Fi Test. Right click on the folder and click on extract here. If you don't have WinRAR or WinZip software to unzip it, then a link is available in the video description to download these softwares. Once it's unzipped, you will get the folder with the same name. Go inside the folder or open the programming file. In the program, you can see the Blink credentials. You need to replace it with your Blink template. So open your Blink dashboard. In the info tab, you will see the firmware configuration. Copy these credentials and replace it with Arduino code. Now we need to add a library of Blink to our Arduino IDE. So go to the video description and download the library. Once downloaded, you will see that you got the zip folder with the name Blink library master.zip. Now right click on the folder and click on extract here. As you can see, all the files have been extracted to the folder with the same name. Copy this folder and go to the drive where you installed the Arduino software. Go inside it and you will get the folder with the name library. Go inside this folder and paste the library here. Now it's time to upload the program to Notify. Connect the Notify to the computer's USB port and here we select the Wi-Fi board to upload the program. So go to the tools and click on board and scroll below and select the NodeMCU 1.0 ESP12E module. If you don't know how to install the NodeMCU Wi-Fi board to Arduino IDE, then a link is available in the video description that will show you how you can install Notify NodeMCU to Arduino IDE. After selecting the board, go to the port and select the COM port as COM8. After that, click on the upload button. As you can see, the program has been uploaded to the Notify Wi-Fi board. Now, time to configure the Blink mobile app. So, go to the App Store and search for a Blink. And for Android user, they can download it from the Android store. Here I got the Blink 0.1 legacy app. That was an old Blink app. Scroll below and below we got Blink IoT New. You need to install this app. As I have already downloaded it, so open the Blink app and here we have got the two options, sign up or login. As we already created an account with Blink, so login to it. Dashboard has been opened. One more thing to remember, that the developer mode option must be on in our app. So go to the profile and open it. As you can see, by default it's on. So back to the dashboard and click on add new device. Here we got three options, connect to Wi-Fi, scan QR code and quick start device. So we select connect to Wi-Fi and the next screen appears. Here we need to power up the Notify Wi-Fi board that we programmed with test code and click on ready. So guys, in this step, for some time we didn't find any Blink Wi-Fi device. So what do we do now? We go to our mobile phone's Wi-Fi setting and search for new Wi-Fi. Once you see any Wi-Fi with name starting from Blink, then join that. As you can see, we got the Wi-Fi with name starting from Blink. Select it. Now back to the app and click on ready. Now you have the pop-up to join the Blink device. Click to join and automatically it will add that device to your app. Now you need to connect your device to Wi-Fi, so select your Wi-Fi and write the Wi-Fi credentials and click on continue. Wait for 5 to 10 seconds to configure the Wi-Fi with your Notify board. Once the profile is created, then click on continue and then done. Now exit from the app, back to the main dashboard of the Blink. We will add the switches in the blank app later after uploading the main program on it. So guys, your device has been successfully tested and connected with Wi-Fi. Now time for main programming code. So go to the below video description and download the programming code for home automation with manual control. Once downloading is done, you will get the WinRAR file with the name Blank2 Home Automation Manual Automated. Right click on the folder and click on extract here. Once it's unzipped, you will get the folder with the same name. Go inside the folder and open the program file. Here we connect 3 switches to the D0, D1 and D2 pins of the Notify Wi-Fi board and 3 relays at D5, D6 and D7 number of pins. Here we need to replace template ID and device name of your project. So go to the blank web dashboard and click on the info tab. Here we got the credentials. Copy these credentials and replace these 2 lines. We define the blank firmware version here. In the next line, we define the blank serial, and in this line, we define the node MCU version. We include the blank agent.h library. We take integer type variable for switches as SW1 switch to D1 pin, SW2 switch to D2 pin and SW3 switch to D0 pin of Notify. Now we define integer type for relays as device 1 relay to D5 pin, device 2 relay to D6 pin and device 3 relay to D7 pin of Notify Wi-Fi board. Here we take 3 counters for 3 switches as CNTR, CNTR1 and CNTR2 and initialize them to 0. We take integer type data mode as 0 for internet availability. We change the data mode state to 1 while the internet is not available in the program. Here we take 3 integer types to store the switch state as SW1 on state, SW2 on state and SW3 on state and initialize them to 0. As we know that we have defined our switches in virtual pins V0, V1, V2 in our blank data stream as you can see here. That activity happens in the blank write V0 function. Here we take integer type as 0 and store the data to it using param as int function means parameter as integer. Here we receive the data as 0 or 1 in S0. Now we compare the S0. If we receive the high means 1, then high the relay pin by using the digital write command. That means our bulb will glow. And here we set the delay of 10 milliseconds so that we can prevent the debounce. Now if we receive the integer as low means 0, then we low the relay using the digital write command. Our bulb will switch off using this command. This is the complete function to control the bulb using the first switch through blank. Now we make a similar function to control the second relay. So we created another blank write V1 function for the second switch. We take integer type S1 and store the data to it using param as int function. Now compare the S1. If we receive the high, then we high the second relay pin, and if we receive low, then we low the relay. Now we create another blank write V2 function for the third switch. We take integer type S2 and store the data to it using param as int function. Now compare the S2. If we receive the high, then we high the third relay pin, and if we receive low, then we low the third relay. So we have written the function for all 3 switches to control the relay. Now we want to control the relay using a manual push button while it is connected to the blank. So here we make 2 functions, one as internet and another is intranet. While internet is available, then we use internet function, and while internet is not available, then we use intranet function to control the bulb manually. As I am using push button to control manually because all the latest technology IoT boards to control the automation are based on push button. It's a latest fashion. So inside the internet function, we read and store first switch SW1 value to SW1 on state variable using digital read SW1 command. While we press the button, we receive the high. After 10 millisecond delay, we release the button and read the same button and compare. If we receive low, then we increase the counter CNTR from 0 to 1. What does it mean? We switch on or off the bulb once we press and release the button. Get it clear? So now we compare the CNTR means counter value. If CNTR is 1 means we press and release the button. Then we switch on the relay using digital write device 1 high command. At the same time we update the switch state of blank virtual pin V0 to 1 using blank.virtualWrite command, so that blank switch set to on state automatically. And if CNTR value is 2 means we again press and release the button. Then we switch off the relay using digital write device 1 low command, as well as we update the switch state of blank virtual pin V0 to 0 using blank.virtualWrite command. And below we put the CNTR value to 0 so that it will start again from 0. So this is how to manually control the first relay. We do the same for the second switch. We read and store the second switch SW2 value to SW2 on state variable. While we press and release the second button, if we receive low, then counter CNTR1 value increased. Now we compare the CNTR1 value. If CNTR1 is 1, then we switch on the second relay and update the switch state of blink virtual pin V1. And if CNTR1 value is 2, then we switch off the second relay and update the switch state of blank virtual pin V2 and set the CNTR1 value to 0. Now we read and store third switch SW3 value to SW3 on state variable. While we press and release the third button, if we receive low, then the counter CNTR2 value increased. If CNTR2 is 1, then switch on the third relay and we update the switch state of blank virtual pin V2. And if CNTR2 value is 2, then switch off the third relay and update the switch state of blank virtual pin V2 and set the CNTR2 value to 0. So our internet function has been completed, by which we can manually control bulbs while the internet is available. Now what do we do while internet is not available? So we create intranet function by which we can control the bulbs manually. We similarly read the switches as we read in the internet function. We read and store first switch SW1 value to SW1 state variable using digital read SW1 command while we press and release the first button and compare. If we receive low, then the counter CNTR value increased to 1. We compare the CNTR value. If CNTR1 is 1, then we switch on the first relay, and if the CNTR value is 2, then we switch off the first relay and we put the CNTR value to 0 to start it again. We read and store the second switch SW2 value to SW2 on state variable while we press and release the second button and compare. If we receive low, then the counter CNTR1 value increased to 1. We compare the CNTR1 value. If CNTR1 is 1, then we switch on the second relay, and if the CNTR1 value is 2, then we switch off the second relay and put the CNTR1 value to 0 to start it again. Now we read and store third switch SW3 value to SW3 on state variable while we press and release the third button and compare. If we receive low, then the counter CNTR2 value increases to 1. We compare the CNTR2 value. If CNTR2 is 1, then we switch on the third relay, and if CNTR2 value is 2, then we switch off the third relay and we put the CNTR2 value to 0. Now time to check the internet status by calling the internet status function. Here we take is connected bool variable to store the blank connectivity to internet by using blank.connected command. If is connected is false, means no internet, then we set the data mode value to 1. Otherwise, if is connected is true, then we set the data mode value to 0 and synchronize the blank to internet using blank.syncAll command. At the setup mode, we serially begin our Wi-Fi at 9600 baud rate. Here we have no need of these commands, so I am going to delete them. Here we define the pin mode of SW1, SW2, SW3 switches as input and define pin mode as output for relay as device 1, device 2 and device 3. we digitally write all of these pins low so that when we power up our Wi-Fi board, it starts with all relay in off state. After it, we have blank agent.begin function to start the blank communication. The main function of this is to set up the Netlify Wi-Fi board with internet as well as blank cloud server. And once it's authenticated with blank cloud, the Netlify Wi-Fi always auto communicate with your blank Wi-Fi app automatically when power up, because it stores all of your Wi-Fi credential into your board's EEPROM. And here is the timer.set interval function that calls the internet status function that is defined here every 2 seconds, so that when the internet is available, it will connect the blank app to the internet. And here in the loop function, we compare the Wi-Fi status. If Netlify is connected to the internet, then we will run the blank agent.run function inside so that blank app will start working online. Here we define the timer run function to run the simple timer that will run the timer.set interval. And here is the main comparison for manual controlling of light through switches. We got the data mode status from the internet status function. If data mode is 0 means the internet is available, then we call the internet function that we defined here. And if the data mode is 1 means no internet, then we call the intranet function. Now I will upload the program to Netlify. We connect the Netlify Wi-Fi to the computer's USB port and select the NodeMCU board and COM port and click to upload the program button. As you can see, the program has been uploaded, and now I open the serial monitor. As you can see, Netlify has been connected to the blank cloud and ready to ping. So now time to connect the hardware connection with Netlify. So guys, this is the 2-channel relay. This terminal is NC, means normally connected, middle terminal is common, and last terminal is NO, means normally open. We always make connections between common and normally open terminals. Let's understand the circuit diagram to connect the AC bulbs with the relay. As you can see, we have 3 12-volt relays. Note that pink color wire here denotes AC wire. One side of this wire connected to the one point of AC plug directly. Second side is connected to the common terminal of all relays. Now come to the orange color wire. This is another AC wire. One side of this wire is directly connected to the second point of AC plug, and the second side of this wire connected to the one side of the all 3 bulb as shown in the circuit diagram. Now come to the blue color wire. One side of this wire connected with the remaining side of the bulb, and the second side of this wire connected to the NO terminal of the relay separately as shown in the circuit diagram. Link is available in the video description to download this relay connection diagram. So let's connect it with the real-time hardware. As we already have all the required components, let's interface it to the Netlify Wi-Fi as per the circuit diagram. I have 3 bulbs with holders and red and black wire connected to it. Connect red color wire of all 3 bulbs to the NO terminal of the relay. Now take a piece of wire and connect all the common terminal to one another so that we can provide AC to the common terminal as per the circuit diagram. Now connect all the black wire of bulbs and join them to one another like this. Now we have these wires to connect it to the AC socket board. And yes, I have a AC plug, so I will connect these wires to the plug so that I can connect it to the AC socket. AC connection with relay has been done. Now it's time to connect the relay with the Netlify Wi-Fi board. So I am taking the board in which I have soldered the push buttons. This is the circuit diagram. It will help you to understand it. Here, red color wire denotes 5 volt DC and blue color wire denotes ground. One side of all 3 switches directly connected to 5 volt DC, and the second side of switches connected to 1, 2 and 3 number of header pins. Each pin connects to the one side of 10K registers separately, and the second side of the register connected to the ground. You can download this circuit diagram from the link available in the video description. Take 5 female to female connecting wires and connect to the headers of the push button. Here from the top this pin is ground, then 5 volt DC. After that first, second and third pins of the push button. We connect the ground pin to ground and the 5 volt DC pin to the 5 volt pin of notify. Now connect the 1, 2 and 3 pins of headers to the D0, D1 and D2 pins of notify. You can also tally your connection with the circuit diagram. Now time to connect the relay to the notify. So we take 4 female to female wires and connect them to the 2-channel relay. Now we need a board to provide the external 12 volt DC power supply to the relay because we are using a 12 volt relay. So we take this board, we connect the 12 volt pins of 2-channel relay to the external 12 volt and ground to the ground. Now 1 and 2 number pins of 2-channel relay to the D5 and D6 pins of notify as per the circuit diagram. Now take 3 more female to female connecting wires and connect them to the another relay and connect the 12 volt to 12 volt and ground to ground of external board. Now connect the input pin of the relay to the D7 pin of the notify. Please note that as we are using an external board to power the relay, so we need to common the ground of both boards. We take 1 female to female wire and connect the external ground pin to the notify ground pin. Now time to configure the Blank app. So open the Blank app on mobile. Click on this project template and go inside it. Click on the setting icon on the top right corner and here click on the plus icon. Widget box has been opened. Click on the button to add to your app dashboard. We add 3 buttons. We can replace and resize it as per our requirements by long press on the buttons. This looks nice. Now click on the first button and its property gets opened. Select the data stream as switch 1 V0 and change mode from push to switch and back to the dashboard. Now click on the second button and in the property select data stream as switch 2 V1 and change mode push to switch and back to the dashboard. Now click on third switch and in the property select data stream as switch 3 V2 and change mode from push to switch and back to the dashboard. So we have configured the Blank app and it's ready to control the live hardware. Now I am connecting the USB cable to the notify and providing the power through the laptop's USB port. This is a 12 volt 2 ampere power adapter to provide the power to the external board, and this is the plug to provide the AC to the bulbs through relay. Now I am switching on the AC power. Let's open the Blank app. As you can see, I can control the bulbs via Blank. Now I am going to control it manually. While I press the switch, the bulb is glowing, as well as updating the button status on the Blank mobile app. So this is how we can control the AC appliances through Blank mobile app, as well as manually while the internet is available. Now I am switching off the internet. It will take nearly 20 to 25 seconds to completely start work offline. As you can see, it's not operating through Blank mobile app as it's in a offline state. And now I will try it through the switch. That's great, it's operating through a manual switch. You can also control it through the web dashboard of Blank. So go to your Blank dashboard, click on search and select your project template. And you can control it by clicking on the button. So guys, this is the complete project to control your home appliances through Blank 2.0 with manual control. And if you want any kind of help on your project, you can contact us as well. If you feel any query regarding the project, write to the comment box. All the information and links related to this video available in the video description. You can download it from there. Thanks for watching. Kindly like, share and subscribe our channel and videos.